Hello and welcome to day 2 of Advent of Code. I already solved it. However, I had an audio issue which meant the video is unusable. Thankfully, I solved it using a really not so clean method, so in this video I'll be focusing on creating a very rusty way of solving it. So let's first look at the issue. We are given a single line of comma-separated ranges, and so this range goes from, for example, for 11 to 22, and the idea is that in this range there are valid and invalid numbers, and the goal is to just sum all the invalid numbers. That's how easy it is. Now, what is an invalid number? An invalid number is a number which is, in this case, in part 1, it is, for example, twice some other number, right? So 6464 is invalid because it's double 64, and 123 is invalid because it is double 123. I thought it'd be interesting to just go straight to part 2, because here it is not only 2, but it can be any amount. So 123 or 123 is also invalid because it is 3 times 123. And 1234 here is 2 times 1234. So it's still the same as before, but now like 7 ones is also invalid. So I thought it'd be much more interesting to just start with that, because this subset completely subsumes this one. So, I mean, you can already see that I completed it, right? But I'll be making it more rusty this time. Okay, so again, what are we dealing with? We're dealing with ranges, invalid number checks, and parsing. So let's start with parsing, right? We have a file right here. This is the test input. We want to input this and parse it into ranges. So that's what I'm going to do. I'm going to start with a struct. Let me fix my keyboard. Hope you can see the screen well enough. We start with a range. It's going to be a beginning and an ending, as you can see here. Beginning and ending. So begin, U64, and U64. Now, why did I pick 64 bits? Because some of these numbers are really big, and they do not fit in a U32, a 32-bit number. So that's why I'm picking these. And I want to create a parse function, so parse range. I'm gonna get a range representation, which is going to be can be referenced as a string. I'm going to return a result. So either it's going to be okay, here's a range, or we're going to get an error. So let's create the error. Range parsing, or like parse range error. What the exact variants are, we don't know yet, but we know we are going to encounter them, because parsing can always go wrong. Okay, so what are we going to do? We're going to get a string, and the idea of this string is that it is this right here. So first we're going to trim it. Okay. Then we are going to find the first dash, and then everything before it is going to be the beginning, and everything after it is going to be the end. So let's just do that. Let's begin and equals trimmed dot split once is the nice Rust function that just finds one character and just gets everything before it and after it. Problem is, the string that you're calling this on may not even contain this character. So this function returns an option. However, we know that we can expect it. So we're going to say expect valid representation. Okay, that will be that. And then we actually we won't do this because we're returning errors. Missing dash. Let's do that. That's a lot nicer, right? So either this is okay, or if the option gives none, like, oh, we don't have the dash, then clearly we're missing the dash. So we're going to throw that error. And then we're going to parse. So I want so these are strings, right? So we want to parse until it's a U64. So this should be begin.parse. Again, parse gives a result. So we're going to have to map the error variant until a invalid, let's call it invalid range bound, and let's pass the actual, the wrong string. So we're doing this, and then it's beginning that's issued. I did the same thing in the first video, right? So let's do that, and let's do the exact same for end. Okay, and then we can return. Finally, we have all the info we need, so we can return, okay, here's the range with a beginning and an ending. So now we want to parse the thing. So that input text is, we're going to use the file system API. So read all string, read the string. I'm going to say, well, we're going to start with test.txt, right? Okay, I'm going to read the string. This one we are going to expect file gist. Okay, so now we got our string, which is just gonna be this whole thing, right? We're gonna say like, okay, let ranges equals input text dot split. We're gonna split at the comma, and then we're gonna map all the splits onto this function. Well, the other way around. This function we're gonna map onto all the strings. So we're gonna get all these results, and then we're simply gonna say unwrap the results. I don't care. Right, so if we find an error value, we unwrap it, and we just crash the whole program. It's fine because we expect this to be valid. So once we do this, you can see that we have an iterator of ranges, which is typed. So now we can continue. So what I want to do is I want to kind of glue all these numbers together and just iterate over all of them at once, and then sum them, right? So my idea is to kind of do this. That sum equals. So we want some way to turn ranges into iterators. And we want to flatten those and then sum them, right? That's kind of what I want to do. So to actually iterate over this custom struct, we're going to impl into iterator for it. For the struct. Okay. The item that we're going to iterate over are u64. And we're just going to say self.begin, self.end. It's inclusive. The type of this thing is range inclusive. So let's just say that that is the into iter type. I did not copy paste that correctly. And we don't need the brackets. So now we effectively told Rust that, like, hey, you can consider this thing to be iterable, right? So that's exactly what we want. So now we want to say into iterator, into iter. Okay. The unwrap here doesn't work because this one needs to have debug, which is fine. We can do that. Okay, we don't know what to sum into, which is this, and then we can print. Okay, so what this is doing right now, it's just going to sum all of these numbers, right? We don't want to do that. We want to filter to sum only the invalid ones. So we're going to do that. Filter. We're going to create a function to check, or like to determine whether a number is invalid. We're just going to say this for now. So we want to filter on invalid numbers. It does take it by reference. Right, so this is essentially what I want to do in main. So now comes the crux of the issue. Remember what makes a number invalid, right? A number is invalid if any combination of substrings is like repeated, or if the number is a repeated substring, right? So I want to make use of a fun little divisibility trick. For example, 1 2 3 1 2 3. That is essentially divisible by 0 0 1 0 0 1. Right, and that's what makes it a duplicate value. And the same can be said for 6 4 6 4 6 4, for example. That's just this string right here. So we have some spaced ones, and if it's divisible by the spaced ones, exactly, then it is an invalid number. That's what I'm claiming here. So first we have to find these blocks, right? So this is a 6-digit number, so we have to check these two things. We check, oh, either it is twice a 3-digit number or it is thrice a 2-digit number, right? And if it's 4 digits, you only have to check, hey, if it's twice a 2-digit number or 4 times a 1-digit number, right? So we kind of have to go over all the divisors and then build this check value, these spaced ones, and then check, hey, is this number perfectly divisible by this? If so, it's invalid, right? So that's exactly what we're going to do. So we're going to go over, so first we're going to calculate the amount of digits in num. And for this, we only need the logarithm. Now the logarithm here is rounded down. We want the amount of digits, so we have to add 1. For example, like if you say like 30, right, the logarithm is going to be 1 point something, but it's 2 digits, so we add 1. Does it go right when it's 10? Yeah. Logarithm of 10 is exactly 1. We add 1 is 2 digits. Yeah, I think it's fine. So we're going to iterate over all the possible chunks, all the possible like lengths in the digit, right? So if the digit count is 6, we're going to check like 0, 1, 2, 3, 4. Well, not 0, 1. We're going to check like 1. Can we repeat 1 6 times? Can it repeat 2 3 times? Can we repeat 3 2 times? 4 is invalid, right? I mean, 4 isn't a valid chunk candidate, and 5 is not a valid chunk candidate, right? Because you can't repeat a string of 5 to get 6, so it doesn't make any sense, right? So we want to filter on, so we have a chunk candidate. We only want perfectly divisible stuff, right? So we're gonna say like, hey, only take the ones which are perfectly divisible. And then let's insert again. Then we're going to check whether any of the chunks that are valid, if the spaced ones string we build, if num divides that, right? So num divides the spaced ones equals 0. And spaced ones are going to be derived from the chunk. So let's make that spaced ones. So remember, so spaced 1s 3 4, for example, makes 1 2 3 4, and each of these is 3 long, right? So we're checking if a number of 3 digits is 4 copies, right? So we have chunk, I guess, block size U64, block amount, block count U64, and we're going to return a U64. And again, this is just a simple like iteration. As you can see, like I'm using a lot of these like functional things because this kind of problem is like inherently stateless, right? It lends itself towards these functional solutions. So we're going to iterate over the block counts. We're going to map each of them to a power of 10, right? So 10 to the power of, well, I want 10 to the power 0, 10 to the power 3, 10 to the power 6. So we're gonna take this as the power index. It's gonna multiply by the block size. That's what I meant by 0, 3, 6. These are multiples of 3. And then we're gonna sum all of those. It's ambiguous. Well, we want a U64. And these are expected to be 32-bit numbers, which is fine because we expect these to stay small, right? Because they're only talking about the length of the number in decimal. So we make that. Namely, we take the block size is this chunk. That's what we're iterating for, right? And then digit count divided by chunk. And this should really be it, right? So let's check it on the test input, 4174. That's exactly what we get here. And we can test it on the, we can actually run it on the input text. And let's do a proper cargo run release. And we see 368622814. Funny, you can still see the history of my live attempt. But yeah, and that is the solution. I hope you enjoyed this this coding session, and I'll see you for the next day. Bye bye.